Here's my answer. We'll go diagonal by diagonal. The first one is easy, since it's just the cost of the pairwise product. Next, we'll consider this entry here, corresponding to the product of ABC. First, consider breaking it up as A times BC. That would be 0 for computing A, plus 9 for computing C, plus 6 times 3 times 3 for computing the product, for a total of 63. The other partition, AB times C, has cost 18 for AB, 0 for C, and 6 times 1 times 3 for combining the products, for a total of 36. That ends up as the smaller of the two possibilities, so we'll go ahead and write that information in the table here. Now we move on to the other entry along this diagonal, the one for the product BCD. We'll consider first computing this as B times CD. That costs 0 for B, 24 for CD, and for computing the product, 3 times 1 times 8, for a total of 48. The other partition, BC times D, has cost 9 for BC, 0 for just grabbing D, and 3 times 3 times 8 for the product, for a total of 82. 48 is the minimum cost, and the better partition is B times the quantity CD. So we'll record that information in the table. Now for the last entry. Consider first the partition A times the quantity BCD. The cost of A by itself is 0. The cost of BCD was 48, and the cost of the product was 6 times 3 times 8, for a total of 192. The product AB times CD costs 18 for AB, 24 for CD, and 6 times 1 times 8 for combining these products, for a total of 90. Lastly, we have this partition, the quantity ABC times D. ABC costs 36, D by itself costs 0, and the product costs 6 times 3 times 8, for a total of 180. The middle one here is clearly the best, so we record that fact, and that gives us the partition, which we can write in these squares like so.